This is TWIS. This Week in Science, episode number 969, recorded on Wednesday, May 8th, 2024. Where are all the science moms? Hey everyone, I'm Dr. Kiki, and tonight on the show, we are going to fill your head with light, leprosy, and little implants. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer. Kids these days. It's a phrase often spoken by people of a certain age before detailing all the things they think are wrong with the current generation of young people. And being of a certain age myself, I think it's time that I weigh in on kids these days. Kids these days spend a lot of time on social media watching the YouTubes, the influencers, and playing video games online. In my day, we didn't do any of that. Online hadn't been invented yet, for one. Instead of getting information from Google, where you get a lot of information that requires some level of source scrutiny to differentiate good sources from bad, in my day, we asked our questions to slightly older kids and went with whatever they said. We hung out at malls, watched whatever was on television, and only played video games if we had enough quarters. Kids these days are anti-war, anti-fascist, and anti-corporate greed. They're also pro-gender equality. In my day, and in your parents' and grandparents' day, the youth was also anti-war, anti-corporate greed, and pro-civil rights. Your great-grandparents are called the greatest generation, and they invented anti-fascism, fought against it, and won. They would be proud of you. Kids these days don't want to work dead-end jobs for low pay, neither did your parents or grandparents, and their dead-end, low-paying jobs had more purchase power than yours. Kids today believe in a better future than the world as they found it, and that is something that has guided every generation, and why kids of every generation love This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Science to you, Kiki.
And a good science to you too, Justin, and everyone out there. Welcome to another episode of This Week in Science. Woo! We are back again to talk about all the science news that we thought would be fun to discuss. Oh yeah, we've got a ton of stuff, and oh my, kids these days. I do want to take a little aside and considering the kids in the world, just want to say, hey, all you science moms, it's almost Mother's Day, and all you science moms doing the science and the momming, I want to say you're amazing. You are, and it's not easy what you do. And if you feel like
you can't even have kids these days without moms these days.
No. But science also helps a lot as well. But I'd love to hear from the science moms out there. Send us a note about your experience as a super science mom. And I'd love to share your amazingness with the TWIS community if you would share it with us. That would be great. Everyone out there, though, thank you for joining us for another episode because we have a great show ahead. I'm sure of it. Because I've thought a lot about it. Well, I mean, I have lots of brain stories, whatever. I have new stories about exciting glue balls. Parrot stepdads, bad business, a new look at light, and lots of talk about things and brains. What do you have for us, Justin?
I've got bird flu,
Eh.
cow flu.
No.
I guess cow
No.
flu.
Darn it.
Leprosy. And what you should be eating right now to prevent dementia later.
Well, since you've got all these wonderful diseases tonight, I think maybe you should be eating whatever that is. So I can't wait for you to tell us. Okay. But before we jump into the show, I would love all of you to be reminded that subscribing to TWIS is a great way to support what we're doing wherever you find us. YouTube, Facebook, Twitch. That's where we live stream this video broadcast every Wednesday, 8 p.m. Pacific time. What is it, 5 a.m. in the Central European area? Yeah. Night, morning. And you can subscribe to us as a podcast. All places that really good podcasts are found. Look for us. And when you want to find out more, you can go to our website, or if all this information is just too much, look for This Week in Science in the browsers, in the search engines, or visit twist.org, where our show notes and recordings of shows are held.
And if none of that works, ask a slightly older kid.
Or ask somebody who is wearing a shirt that says TWIS on it. If you meet them, if they have a TWIS shirt, ask them, do you know the podcast? Help me subscribe.
Although if they already know the podcast that they want to listen to and like the name of it, would it really be that hard to figure it out? I think it'd be okay. I think they're fine. I think they're fine.
Kiki. This is science. I know you're supposed to critique people's ideas. Okay, I get it. Let's move on to the science and the questions. Yeah?
Yeah.
Okay, glue balls.
Well, so
what are glue balls? Why are they important? What is the big deal? This is like the big thing this last week.
In theory, but
Yes.
never actually seen, a glue ball is a lumpy, clumpy bunch of gluons?
Yeah, absolutely. That's exactly what it is. Uh-huh.
I knew that.
How did you know, Justin?
I totally knew that.
You
I
did.
don't know how I knew that.
All right, so this is an unusual and previously unconfirmed standard model prediction where it suggests that there's a state where gluons, which we know about, exist smushed together. And so researchers have been trying to smash things together for a very long time to break atoms apart to smaller pieces to see what those smaller pieces do when they're broken apart. I mean, normally, like when a car crashes into another car, they're just smaller pieces, but the pieces of the car don't meld together. But that's not how matter works. And so protons, neutrons, electrons, they're held together by these gluons. And so there's this idea, there are lots of ideas about how this binding takes place. But first you have to figure out whether or not the gluons are binding together. And so there's this new paper, the Physical Review Letters, this last week. And so this may be the lightest glue ball ever discovered, as predicted by the standard model. And this is an exotic particle, and not exotic like coming, I don't know, pythons that shouldn't be in Florida, kind of exotic, but exotic in that it's rarely seen. It's predicted, but they didn't know whether or not they'd really be able to find it. And this gives more information about how our universe is held together. So that's really the big deal here, is that once you start figuring out how the gluons are sticking together and how this particular piece of the standard model, this new discovery, the energy that was released in the discovery, and we say discovery because it's always been there, but this is the first time that researchers have been able to put together all the energy signals in the right order to be able to say that they're seeing this particular thing. Anyway, there's a lot of quarks and there's gluons and there's combinations of all these things. And
the weird thing about gluons is it's like it defies the whole things being further apart and having less attraction, because it's like the more you pull gluons apart, the stronger the reattack. They're kind of like a rubber band as you pull it. It wants to. It's creating more tension to go back.
Yeah, so
like
it
Feynman.
fails.
I think I have some sort of Feynman rubber band analogy stuck in my head is all I know about gluons.
Right, so like gravity, magnetism, all these things get weaker as you pull things apart, right? But then these things, they get stronger. So it's kind of
attraction.
Yeah, they really want to bind to each other. And so anyway, they were able to do some work in Beijing, their electron-positron collider that's BESS-3, the Beijing Spectrometer 3. It's been working since 2008. They've got a whole bunch of particle impact events and have been able to see the energy resonances, things, the decays of particles that come from it. And now they have said that they have discovered these glue balls. However, this is the weakest energy or the smallest one that they've ever seen. So
I thought it was the only one they'd ever seen.
Yeah.
So it's also the biggest.
The biggest and the smallest is light. So, but I think it's the lightest that's predicted by the standard model. So the question is like, why haven't they seen the heavier ones or the more energetic ones? Anyway, the researchers, they have great results according to other physicists. And this is important for really testing parts of the standard model, which to date, we really haven't disproved in any major way. So there are lots of more questions to answer. And so now more work on glue balls needs to happen. And I do hope that in a coming month, I'll be able to get Ethan Siegel on the show, who is an amazing podcaster, science writer. We've had him on the show previously to talk about black holes and all sorts of astrophysics stuff. And so hopefully he'll come back and be able to tell us much more about this particular discovery in particle physics. I think that he would really be able to do that because he's written an article for The Big Think exactly on this subject. Da-da-da. So he'll have more information than I do. So many questions. Yes. Glue balls. Balls of gluons. It's good for us understanding things. Justin, what do you want to talk about?
Texas cows may have a bird flu problem.
No.
And actually a potentially more dangerous reluctance by cattle ranchers problem.
No.
Reluctance to cooperate with confronting, controlling, admitting that there's an outbreak. So this kind of started a while back with reports of sick cows, some increased illnesses in workers, and an alarming number of dead birds and barn cats.
Yeah, the cats also, that's a big one as well. Yeah, we haven't talked about this yet on the show. And yeah, I'm sorry that we haven't discussed it yet, but I'm glad you're bringing this whole thing up. So keep going.
Oh, I thought this was relatively new. So anyway, there's a veterinarian in Texas who has 40,000 cattle under her sort of monitoring care.
Okay.
So she goes and here's all of these reports, sick workers, dead cats, dead birds. She goes and tests for all the typical illnesses that they have on their testing litany, and the results came back negative. Nothing. Not a problem. What? Okay.
Nothing. So, wait, she did the testing or who did the testing? What happened?
A veterinarian.
She did all the tests and they were all negative. Tests. Okay.
They all come back negative. And so she goes, well, okay, so it's something that's not in that. So when you're testing, it doesn't tell you everything that's possible under that in the world. It doesn't come back with every type of diagnosis. Testing is usually going to be for standard diseases you expect to see, because every test is very specific, looking for a specific thing, right? So she takes her sample set and she sends it to the Veterinary Diagnostic Laboratory at Iowa State University. The samples are tested there with a more rigorous, broader spectrum of things that it's looking for. And they come back positive for a bird flu virus never before seen in cattle. It was the first proof.
But this is a bird flu virus that epidemiologists have been and people who are concerned about new flu viruses. They've been watching it for a while.
Yep. But it was the first proof that bird flu, this type A H5N1, could infect cows. Hadn't seen it before. And you know, when you look at how this plays out, veterinarian monitoring 40,000 cattle, all of the tests come back negative under the normal spectrum of what a veterinarian can test for. So they don't see it.
Yeah. Why? Mm-hmm. What happened? Flu. I mean, flu should be, bird flu generally should be part of the testing, right? What happened?
No, because there's no cattle have ever gotten it before. So it's when you have these disease kit testing kits, they're looking for a very specific, perhaps antigen or something in there, and so they're pre-made. They're not just they're not AI based. They're not going to look for every type of thing and match it up to a database. It's pretty simple. So when you have a more, like if you go to a public health lab, there's something where people are getting samples from all over and sending them in, doctors are sending them in to see what it is. This single sample will go through a 600 potential test to see if it matches up to different things.
Yeah.
In the field testing, much more limited. It's looking for the typical things, maybe hoof and mouth disease or whatever the, cattle normally come down with, whatever they come down with. That's what it's looking for. So that's kind of how this unfolds. It's not that necessarily this hasn't been going on before. It's that the field tests have not been dialed in for bird flu because we didn't know that they got it.
But we know that swine, pigs, get bird flu. That's a very not common, but it is something that happens. They're a huge reservoir for the bird flu throughout mostly Southeast Asia and America as also. So anyways, Iowa State University kind of sounds the alarm. Hey. And now that the testing is more dialed in, there's 36 herds in the U.S. known to be infected. This was actually, it may be more than this now, because this story is about a week old. So at the time, almost every farm that had sick animals that was being investigated, there were also sick people. There's always sick people somewhere, yes. But this was like, that reliable, sturdy farmhand who's never called in a day sick in his life, didn't show up. There was a lot of sort of strange illness with this. So far, only 2 people in the U.S. were confirmed to be infected with this H5N1. Well, this was again a week ago. But one of them was a Texas dairy worker, and it was linked to the cattle outbreak, according to the CDC. This is Dr. Gregory Gray, an infectious disease epidemiologist at the University of Texas Medical Branch in Galveston. He has been taking samples from livestock and people on Texas farms with confirmed cattle infections.
But one of the things he says is they seem to be linked in time and space. So one should say it is biologically possible that the infection is going from cow to person. But the problem is, the particular disease is looked at as a scarlet letter. This is actually, Kay Russo, Colorado veterinarian. It has this stigma associated with it right now. Basically what it means is you can't sell your cows out of state. They have to be, if you sell cows out of state, they have to be tested. For all other tests, it's completely up to the cattle ranchers whether or not they want to test their cattle. And so they're not testing because it could get in the way.
Right. If you test, then you know, and then there's a problem.
Yeah. Yeah.
Farmers
have been hesitant
before?
to allow health officials onto their land. And according to Rousseau, we do not know what we do not measure. Unfortunately, the horse has left the barn and took off a lot faster than we were able to mobilize. This is country doctor talk. So all labs that conduct tests must report positive results to the agriculture department. So many farmers have simply decided against testing, hoping to outlast the outbreak. And there's also some reluctance. It says reluctance of workers and farmers. I think the workers. It's sort of like working in an industry where if you speak out, you may not work again. I feel like it might be where that's coming from. So,
well, we know from recent history how infections impact, like very pandemic or dangerous viruses can impact society, the economy, businesses, all sorts of things. So this is, people have been talking about this, and it's interesting to see what's happening. For milk, so far, the result came out, I think it was last week, that 1 in 5 gallons of milk was infected with this avian flu virus. However, because of pasteurization here in the United States, it's not an issue because the pasteurization process does destroy the virus, and that's fine.
Maybe not a time to get that unpasteurized milk.
Yeah, if you're into that thing.
You can still get that.
You can. I mean, other countries have France loves their unpasteurized milk, but the U.S. not so much. But the issue here, though, is can we get people to communicate in a way with the ranchers, with the people who are working to underscore the importance of testing and controlling the spread of this virus, since it is infecting people, but we have not yet seen person-to-person spread. We've got cow to human, potentially. That's what it seems like. Or it could have been cow to cat to human. Has anyone done that? Because there are sick cats as well at the ranches. So how is the virus jumping? What mutations are taking place that allow it to jump? And I don't know, just remember we all wore masks for COVID, flu kind of dropped. Wash your hands, wear a mask if you're concerned.
So the thing to keep in mind is that this is also, cows are so very social animal.
Very social, yes. Yeah.
If you ever look out into a cow pasture with a bunch of cows, they tend to hang out together pretty close. And they're, nuzzling up and saying hello. So it seems like they're a pretty good candidate for it to spread quickly. Cats, the only thing with cats is, especially farm cats, is they're not friends with anybody, not even other cats. But they will encounter birds.
Yes.
Quite a bit.
Yeah. So the next question, is it going to go back and forth?
Yeah.
I mean, if mutation
if
allows.
it's bird, cat, cow,
or however it works. I mean, I imagine there's, a defecation from the birds, the grass gets eaten by someone, or perhaps, I don't know, who's looking at the moles and the voles and the rats and the mice that are on these lands as well. There's a lot that needs to be taken into account phylogenetically that has not yet been reported as far as I am aware.
But I would hate to see a major outbreak on account of nobody was allowed to check the cows.
Right.
Like, it's ridiculous. It's ridiculous, like, especially post-COVID, to be like, well, we don't want to mess with our industry. Like the mink farmers. The mink farmers were in Europe were resisting. Big time.
They lost their minks.
And then they lost all of their minks. And it's like, well, maybe we should have been a little more proactive earlier. Maybe. Avoid
And that's where I think this is where the science communication, public health communication, where understanding the community of ranchers and the people who depend on the ranching industry and figuring out how to speak with them in a way that makes sense. Figure out a way that works with how they work. To make, it's not all or none, right? There can be people working together to help solve a problem.
Yeah.
I believe in this, even though it's not seen very often anymore.
Look,
I believe.
Also, I think that when you're talking about any kind of livestock industry, public health is here. The farm income is here. I'm sorry. It's just how it always is going to be.
Yeah.
There shouldn't be this, like if you're producing food in a factory, the FDA can come in at any point and inspect what you're doing. I think agriculture should be the same way for livestock, and I don't understand why it's not.
Well, it is. That's what I mean.
You're in the process of making the food, even if it's cows in a field.
Yeah. I mean,
or dairy cows, like whatever. I don't understand why there could be the U.S. government can't say like, hey, we're going to send some veterinarian inspectors into your
They
farm
do,
to check
but
the cow.
it's also funding and the ability to actually enforce the regulations. I mean, there's a lot that is in place, but I mean, there are regulations and there is a lot of stuff happening, but it is difficult. But yes, we should all be concerned about the cows, the farmers, the ranchers, the people, the birds, the cats. I mean, fingers crossed that this one doesn't mutate and turn into a virus that gets spread among people. That would not be great. Dun, dun, dun. All right. Shall we move forward away from the flu into the death of baby birds?
Oh no, what happened?
Well, normally when Aucenes or parrot-type species of birds remate the stepdad or the male. I mean, and sometimes even a stepmom will come into a situation. There's a lot of infanticide in the parrot species of birds. They're social species. And, you think, all right, well, you're coming in and they're these babies, but they're not yours. You don't want to take care of them. And you're like, I'm going to have my own babies. So it's better for you, evolutionarily speaking, to kill the stepchildren and then have your own babies. And this has been like the ongoing hypothesis and like what people have basically seen for years and years and years. I have personally seen budgerigards with Yes, the budgies, the what is a common word for them? I'm blanking on the common word for the budgerigars. Anyway, parakeets? Anyway, with blood dripping down their feathered, beaked face because of it was mating season. And
oh gosh.
Yeah, so it is gruesome. It's harsh. Nature's a thing. And so researchers have been like, okay, these parents, it's like when male lions come in and kill the cubs, or, it's get rid of the other baby. Chimpanzees, so many species. We see it over and over and over again. But this new study in the Proceedings of the National Academy of Sciences, these researchers out of UC Berkeley have been looking at green-rumped parrotlets. They're from South America. They're small, so that's why they're parrotlets instead of just parrots, I guess. They have 30 years of observations on these birds, and they looked at what happened to the families when a father died, disappeared, and a stepdad came in. What happened? Did infanticide happen all the time? Was it always? And so this study, since 1988, these researchers have in Venezuela on a cattle ranch in Guarico, Venezuela, they've been watching the birds and checking out what they're doing. And so they made some artificial nesting sites out of PVC pipes and put them through the ranch, and they banded a bunch of them so that they could see who was doing what where. And they found, in some cases, dead babies in some of these artificial nesting sites, but they didn't know exactly what was going on. And these artificial nesting sites, they're very similar to these other kind of tree trunks and other things where the babies might be raised by their parents. And so one of the graduate students of this researcher was like, okay, why did they die? Was it stepdad or was it something else? And so they discovered that
this is a just in time for Mother's Day story.
Yeah, hey dads. No. So anyway, the researchers were like, okay, yeah, we found a stepdad or a male who didn't belong there exiting the nest with blood on its beak. Quote from the researcher. This researcher, Beisinger. So they've been looking at it. They have 2,700 nests, 30 years, checked it all out. And what they found is that it doesn't always happen. It's not always death to the babies. That sometimes stepdads come in and they take care of the young. Those stepdads are usually a little bit younger than the average parrotlet dad. And then they seem to actually have longer, better, more reproductive relationships. So they end up having at least as many offspring, if not more, than the offspring, than the males who would kill the babies. So,
which would be older males also, so they'd have less time?
Possibly, yeah. So the question is, what's going on with regards to resource competition? This is a species of bird where there are not as many females as there are males. There's lots of males. There's a lot of competition over nesting sites. So there's a lot of fighting among the males. The babies are getting wounded. This is not a nice, friendly, little tiny green-rumped parrotlet society. No, this is competition. They found that the attacks on the children occurred more often when the parrotlet population was high and there was higher competition. And the researcher, co-author Carl Berg at the School of Integrative Biological and Chemical Sciences at the University of Texas, Rio Grande Valley, Brownsville. This quote is great. At low population levels, it's all love and peace, right? But when you get to high population densities, it's a bloodbath. So anyway, the males, they want to breed. They're driven to breed. And sometimes it works to kill the babies that aren't yours, but the fitness strategy is not always the best strategy. And so this suggests that the males who adopt unrelated offspring nest with widowed females. They start breeding earlier. And the head researcher, Beisinger, says, stepfathers scored love, a new mate, and real estate, a nest site. Anyway, the UC Berkeley press agent who wrote this press release is fantastic, but I think it's I really do appreciate this study because it does give new ideas for why these kinds of strategies exist, and that they don't always exist within species, and that there are evolutionary trade-offs for tactics like infanticide and the success of
there should just
reproduction.
Always be a downside.
Yeah. There should be. It should be. But...
Can't think of one, but there should be.
You would think so. Yeah. Anyway. Yeah. Nasty little green-rumped parrotlets. Tell me something else, Justin.
Oh, evidence from archaeological sites in the medieval English city of Winchester. Not to be confused with the medieval Spanish city of Winchester or the medieval
I don't know.
Middle Eastern
places.
city of Winchester. English city of Winchester.
Mm-hmm.
Shows that strains that caused leprosy in people during, I think, a centuries or multi-century long outbreak of leprosy came from not evil spirits, not unclean thoughts, not even rats, fleas, or witches' curses.
What about red squirrels?
That's exactly
They're plague
right.
carriers. Wait, what?
That's exactly
Oh,
right.
I thought that
the
was
English
the black...
red squirrel.
What?
Genetic analysis was able to identify red squirrels as the first ancient animal host of leprosy, according to researchers at the University of Basel in Switzerland. Leprosy is one of the oldest recorded diseases in human history and is still prevalent to this day in parts of Asia, Africa, South America, and of course, Florida. People, places where...
Why did you say, of course, Florida?
Because Florida has a yearly surge. Look for leprosy. Florida, just Google it, and you'll see every year they have a surge of leprosy there.
I did not know that.
Also,
one
hints
more
of it
thing.
in other states.
Yeah. Okay.
So the common denominator may be places where people eat squirrel.
Okay. Keep going.
So, if you don't know, small game is still a thing in the U.S. Parts of the U.S. Up Tennessee, down in the South, and especially popular in Florida. It's also apparently big in Vietnam, according to just Google researching without vetting sources. So anyway, until now, it has been pretty unclear how leprosy may have spread to people from animals in the past. This study kind of looked at 25 human and 12 squirrel samples at 2 archaeological sites in Winchester. So Winchester was, in the medieval days, well known for its leprosarium. which is basically a
The
big
place where they
bed and
put people
breakfast.
who had leprosy, right? Yes.
Yeah. People.
Yeah.
It's a place for people with leprosy to hang out sort of away from everybody else.
Oh my, oh
Winchester also had another thing it was known for, which was the fur trade. In the Middle Ages, squirrel fur was fashionable. The fashionable choice to trim and line garments. Many people may have even
See
kept
that?
squirrels as pets.
I would
'Cause there was
not,
so
but
much-
I can see their little fluffy tails as being something that people who like that kind of thing, fur, would be attracted to. Yeah.
You know, people kept pets because they were trapping. They would trap them in the wild, and occasionally they would trap like a very young one. And so, it's this one's not big enough to eat or turn into trim for a hat, and so you might try to raise it in a cage, and then if it's little, it's like, hey, this one's like knows its name and is always happy to see me, and then
And then you can put it outside, and it might attract other squirrels.
Yeah, and it gives everybody leprosy. So research was sequenced and reconstructed 4 genomes representing medieval strains of leprosy, including one from a red squirrel. And they also looked at some ancient-y, middle-aged people strains that they had. And they found that the medieval squirrel strain is more closely related to human strains from medieval Winchester than to modern squirrel strains from England, indicating that the infection was circulating between people and animals in the Middle Ages in a way that, of course, had not been detected before. It was always thought to be evil spirits, unclean thoughts, and witches.
I think we've been away from the unclean thoughts and witches for a while, but it's interesting.
Actually, when you say we,
I shouldn't ever.
If you're talking about the Hmong people in Vietnam, this is still a cause of leprosy.
Okay.
So, we need to all get illuminated by the light of science all at once for us to say we, I guess.
Don't keep pet squirrels. Avoid the bacterium that the red squirrel harbors, right? Because it's close, but it's not the same anymore as it used to be. But it's still there's still an outbreak.
It's just a different strain because it's now been circulating and evolving for all this time. But the point is that
it's much better at its job.
When where does leprosy come from? Why do people in Florida keep having these leprosy outbreaks? Now, unclean thoughts, sure. Witches, of course. Evil spirits, plenty in Florida. But also squirrel meat. Okay. Yeah, small game hunters. So as we look at things like COVID-19, outbreaks, this bird flu that's now cows, cats, birds,
Creutzfeldt-Jakob.
Who knows, like you were pointing out, who knows what else?
Yeah, there's this Creutzfeldt-Jakob, the quote-unquote mad cow. They're deer. Hunters are being exposed to the prion.
Yeah. Deer also had the
contagious protein folding disease.
High reservoir of COVID as well.
Yep.
In deer. And so when we look at this thing and say, oh, it's a bird flu, it's only in birds, or it's this disease or that disease, or whatever it is, you got to realize, like, even if it hasn't hit humans on a large scale, it may be running through the animals and requires a form of really close contact repeatedly, maybe, for it to jump into a human host.
And we've been doing it for a very long time. And so, like I said, these bacteria, they're like, hey, I like you. I know what to do. Yes. Food. It's fantastic. But yeah, at the same time, we're getting at, I said we, right? Who's we? That's my...
You and me.
Right. Us. Right. That's my educated white lady perspective, from a Western perspective. And so I'm putting my own biases on it that were unconscious when I said we.
Yeah.
And that's
It could
just use of language.
absolutely
But
be witches, evil spirits, and unclean
no,
thoughts.
I mean, but I'm
Certainly.
saying that in
That's just as
in
real a
different
possibility.
areas, people are thinking different things. So I say we're on a
Yeah, and
science
they're
show. I
wrong.
say we. But if
Yeah.
anyway, this gets into my next story. It's a segue.
I didn't know we were transitioning. I'm sorry.
We're transitioning
I'm just
because
pushing back. I'm just pushing back. I'm like, what are you talking about? No, there's a right answer. Well, there can't be a wrong answer. Science has proven there's a right answer. Come on now.
some researchers from North Carolina State University's Poole College of Management did some work in Kenya in an area, and this is a quote from Erin Powell, the corresponding author of the study, who actually is an associate professor of entrepreneurship at this College of Management. She said this area is where society is collectivist. Everyone is accustomed to sharing what they have and supporting each other to the best of their ability, but it's also impoverished. And so they designed an entrepreneurship program to help people in the community start businesses that would help them financially. They wanted to understand the religious backgrounds, faith backgrounds, how that informed entrepreneurship. So they got people in rural, impoverished Kenya to start small businesses, and they helped them do that. And they gave them a model to follow to start doing that. But it wasn't great.
No. Look, you have a collectivist society where people are sharing and helping each other in every way they can. And you're like, no, here's a way to be selfish and
hey,
capitalism from the
capitalism.
rest of your society. Here's a way to do things completely against the grain. It's like being collectivist in a capitalist society. That also probably doesn't work too great.
Yeah, so it wasn't great for the entrepreneurs or other community members. They did in-depth interviews with 25 participants in the program, and this was over 4.5 years. They also visited the villages and observed this stuff and the interactions between the entrepreneurs, the people in the villages, and everything. And the community wasn't happy, right? They're like, wait a minute, what? We share stuff. And now all of a sudden you're asking me to pay for things for like, what? And so there was what they say, social friction, and entrepreneurs were threatened with being cursed.
Yeah, there you go.
Yeah. But they found that there were some individuals who continued. They were able to rationalize their entrepreneurship because in those cases, their religious backgrounds actually played a role. And so some of them were traditionally religious, were afraid of the curses and were like, I'm out. Others were able to kind of make a break between what was business and what was their personal life. And they were able to continue with that because they were like, oh, no, this is not me personally. It's my business. So the curse is not going to affect my business. And like, this is going to be fine. It's going to be great. And then there was another subset who identified as Christian. And because they were Christian, they felt protected from the curses because it was not a traditional belief anymore. And so the compartmentalization was totally different. I think this is just a fascinating paper, the title "To Profit or Not to Profit."
You're charging
founder
me for the bread. You're charging me for the bread. My cousin brought you the flour. I personally brought all of the firewood that you used. I dropped that off as I was going around, dropped off firewood to everybody else. And somebody else even collected water and brought it over for you to do your big. And then you put it together. I get it. You put time and energy doing that. But you didn't collect any wood. You didn't collect the flour, and you didn't collect the water. And now you're charging people. This is the problem with being the entrepreneur. Which I that word in the way that it's used in the U.S. nowadays is like, hey, are you delusional? Do you want to think rich while losing money? Here's how.
You too can
Buy
be
my
like
book.
me.
Yeah.
Yes.
Or
So
people
the-
who are
the-
already wealthy from inherited wealth calling themselves entrepreneurs?
Yeah.
No, you're not an
No,
entrepreneur.
they're not.
You just had enough money to
No,
burn
they're-
through before.
Yeah, they're thought leaders. They're,
Stop.
they're
Oh, the
whatever.
word
Okay, anyway.
entrepreneur.
But anyway,
Everybody who's doing that is in that.
The important take
Ripper
home for this is, oh my God, the way we think about money and business and all this stuff. If we're just like, we're going to pick up what we do and take it to another country and just tell them, we'll teach them how, teach a man how to fish, our way. Because of course, their way of fishing isn't good, So the researchers say that if you're overseeing programs focused on introducing entrepreneurship to alleviate poverty, maybe you should actually take local cultures and context into account.
Yeah.
Do I have to say this out loud? I guess I do.
Yeah. You do. Because, but again, anyway, I want.
Yeah, there's so much to talk about, but we got to get through a few more stories before you have to leave very soon. So we're gonna
roll.
We're gonna bucket through some things. I just want to say, very quickly, a study came out a couple of weeks ago. Wanted to talk about it, but we didn't have the show last week. What they're calling is a photomolecular effect discovered by MIT. This is something people have had this question forever about evaporation of water from the surface of things. It's like very often the math doesn't work out because what you would think of the vaporization based on the heat that would cause condensation, vaporization, like water leaving a body of water and going into the air, it's never quite worked out. There's always more water in the air than they had accounted for. And so these researchers at MIT just figured this thing out, photomolecular effect, which basically means photons of light are bumping into the the molecules of water and breaking them apart. That there is they're bumping into each other, and the energy of smashing photons into water molecules leads to more vaporization. Anyway.
So
people didn't, this is like crazy. And the effect is strongest when light hits water at an angle of 45 degrees. Also with transverse magnetic polarization. And green light apparently is the best. So if you want to start working in desalination or in anything that has to do with cleaning water and blah, 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 vaporization, these are the things that you need to think. They don't understand why green light is the thing that works the best. But anyway.
So.
New news.
It's still the sun that's doing a lot of.
But not the heat. It's not
the heat. It's the light.
The light interacts with water and goes, go in the air now, water, and it does. And that's what happens.
So, but there's also heat is also, does it though?
It does. No, that's a part of it. And that's what we've calculated for ages. That's the physics that has been calculated for ages. But nobody took into account the actual molecular interactions with the light, the photons. And
there's also the existing humidity in the air can determine whether or not evaporation occurs, even under heat conditions. It's so. There
are so many things to take into consideration. I'm so glad everyone is here to consider all these things with us. This is This Week in Science. If you are loving the show, make sure you share it with a friend. And you can head over to TWIS.org to access a link to our Zazzle store. Also to our Patreon, where you can support the show in an ongoing fashion. You can decide to support us as a patron for whatever amount you're able to give, $10 and more per month, and you will be thanked by name at the end of this show. We got a whole bunch of people doing that. And, I know people have financial difficulties, and I see some people who have had to turn their donations off. And, just keep listening to the show. Tell people about TWIS. I just hope you keep enjoying it. But, we really cannot do any of this without you. So for all of it, thank you for being here and thank you for your support. Hey, Justin, do you want to tell me a couple of stories or do you want me to talk about brains?
Oh, I can do it. I just got to check. I got to check the train schedule for the day. It's a holiday here in Denmark.
So things are
today.
Different.
It's a holiday here. I don't know which one because they have like way more holidays. There's like a lot of holidays.
I love holidays.
And it's not the Liberation Day. I thought that was last week. But anyway. So this next story is the Neander face. And this is not even a story. It's just this link. If we can share, do you see
Is it like my face? Neander face. No,
well, let's pull it up. We'll do a second.
I'm gonna do this. Hold on.
You're scaring my face. This is not the Neander face.
Yours is not?
It's a little Neander-ish.
How much Neanderthal do you have?
Like almost none.
Oh, well, I have more than you, so
I was actually disappointed at how little Neander.
I'm sorry. Okay, Neander face. Dun, dun, dun. We will see this from Eureka Alert, which is amazing at sharing these press releases and bit of information.
There we go. So this is the as it says there, reconstructed face of a 75,000-year-old female from the Shenandar cave. This is in Iraq. This is one of the sort of more famous early Neanderthal sites that became very publicized for the burials.
Oh, right. Burials with flowers and the idea that Neanderthals.
So they thought there were flowers, but there weren't. But it's actually kind of even more interesting because I think they've since determined that I think the current version is that it was burrowing bees that had dropped all the pollen that they found. But what that means is it actually, while it took away like the flower thing, which people thought was really like this neat level of like, excitement about, they left flower at offerings to their dead. It actually ends up reconfirming the notion that they were intentional burials as opposed to, falling into a ditch and having dirt fall or the cave roof fall on you or something silly like this. Because the burrowing bees are attracted to loosened soil. So what it looks like now is that the places where these Neanderthals were buried was dug out first, and then several hours have to pass for burrowing bees to find it and decide to drop pollen and burrow into it. And then, only then were the Neanderthals placed in it. So it shows a very intentional burial that wasn't also just on site, but like it was dug out in advance, and then the dearly departed were then laid to rest in these. So yeah, face of the Neanderthal woman though, reconstruction, and she kind of looks very modern human-y. Doesn't seem to have merely. Can you bring that photo up again? Oh, I can't hear you though. I don't know what happened.
Turn myself. It's a flattened skull. So it was in the sediment. It was flattened, and then they reconstructed it to create. Took all the pieces like a puzzle and made it a 3D skull, and then recreated the face.
It's interesting though because there's some brow ridginess there, I guess. It just doesn't seem quite as pronounced. Maybe it's just the angle of the...
Or maybe it's because it's a female as opposed to a male. Maybe female Neanderthals didn't have as prominent of a brow. I don't know these things. I'm just asking a question. Yes. Somebody knows.
She seems like pretty modern human-y. Doesn't, not to, hey, and they gave her a little smile. Just have a nice day. Good day in the cave.
I love the modern techniques that are being used to reconstruct this ancient people, right? It gives, when you can see a face, it makes things more real. Even if it's a T-Rex, right?
Yeah.
Get it right in the movies, dudes. But anyway.
Final story for Mita. As a team of nutritionists and medical researchers at the Harvard T.H. Chan School of Public Health has found evidence that daily consumption of olive oil may reduce the chances of developing dementia. So this is kind of it's a correlative study in a sense, although it's sort of picking apart another correlative, which is the Mediterranean diet. So in a couple of different databases they put together from more than, the researchers studied patient data for more than 60,000 women, including the Nurses' Health Study, and more than 31,000 men in the Health Professionals Follow-Up Study. Both databases include historical information following patients for up to 30 years. Researchers found that 4,751 of their 92,383 patients listed in the two databases had died from dementia-related causes. In comparing diet information, they found that those who had consumed at least a half a teaspoon of olive oil per day over the course of the study's years were 28% less likely to have died from diseases related to the development of dementia. So this is a big correlation of one data point of olive oil.
Fish oil is also supposed to be really great for
but it's not part of this study.
Brain.
It's not part of this
yes.
study. And actually, it may be killing people. Be careful of fish oil. It may
definitely kills
everyone.
fish.
But the other flip of this might be true, that olive oil doesn't keep you healthier. But if the inverse was that other people were using butter, meaning that butter leads to dementia at higher rates, and that olive oil just keeps you at the plateau. So it's all correlative, and it depends on what angle you're attacking this from. But what I think was interesting about this is it performed better than the Mediterranean diet as a whole.
Oh, that's interesting. So just the whole, eating that everything they recommend.
So then you can almost get to the point where you're drilling down and saying, okay, what is it about the Mediterranean diet? Maybe it's just the olive oil.
Olive oil.
that could be the, So when you have these correlations, part of what you're supposed to do is then sort of eliminate other factors. And you may still have correlation and after correlation all the way down, but at some point you might go, okay, we've actually eliminated so much of the other correlations that we're now at getting to the causal. This is still a long way off, but yeah, olive oil performed better, and mayonnaise kills people. Mayonnaise,
but the interesting thing, so mayonnaise, if you're really making your own mayonnaise, you make it with olive oil.
No.
You can make olive oil mayonnaise.
Mayonnaise is fine. It's butter. I'm sorry, butter is killing everyone.
There's a lot more stuff in the butter, but I think this is very interesting.
No. It's other vegetable oils. Yeah, I don't know. I don't know what you've got up there, but yeah.
I think this is a very interesting question. Just off the top of my head, from basic neuroscience and dietitian, nutrition science. Excuse me. Fats are good for you. You don't want to have everything in moderation, right? But your nervous system requires fats for its insulation. That is what maintains the myelin sheath. That is what maintains fat. Like fat is important for your brain. So it may be that olive oil is a more accessible type of fat for the nervous system. I mean, because they're specifically looking at dementia. But I think this is a very interesting question. And I hope that that it's figured out at some point. Why the heck? But I love olive oil. It's great. But I don't always use it because there's other things that are good in life too.
I actually like this study also because I've already almost exclusively used olive oil for everything. So
I'm not going to scramble my
it's
eggs in olive oil. Sorry.
It's just
not gonna do it.
I like it because it's convenient because I've already done it.
It's great. It's wonderful. Olive oil, yeah, it's amazing. But you can also do olive oil mayonnaise. It's a whole thing. You can make your own. It's very delicious. But I think this is very interesting. Why? Now, I hope, correlation, we don't understand it. We do know that dairy-based kind of fat products do have a less healthy effect most often. But
I didn't
single
realize the time
study's not great.
My alarm just went off. I gotta go.
You have to go?
I have to run like now.
Okay. You have to go. I have so many cool brain stories to talk about. Okay.
You can bring them. You can bring them without me. I just can't be here. I have to go.
Have a wonderful day. I'll see you next week. All right. Oh my goodness. Now it's just you and me, everybody. Well, it's just you and me. And we're going to talk about things in your brains. Mm-hmm. That's what I want to talk about now. Because as we've talked about olive oil being good for your brain as you age, potentially, I don't know. It's not just the Mediterranean diet. Turns out that your brain works better thanks to cartilage. What are we talking about? Oh my gosh. There are cartilage-like structures that have been found in the brain, and they are like a scaffolding that hold neurons together in clusters. So if you've ever taken chondroitin, calcium and chondroitin for your knees, for the cartilage and the helping to support the structures that are part of your joints, might also be helping your brain as well. This study finds that there are what are called chondroitin sulfate clusters. They call it CS6. And as a result of their experimental manipulation, the CS6 they found is necessary for synaptic plasticity. So when you learn new things, when you change behaviors, and all this stuff, we talk about, oh, their brains are so plastic. It's like a great thing we learned in the last 20 years, right? It's because there are little scaffolds that are holding little neuron clusters together, and they allow those clusters of neurons to respond to environmental stimuli, and they are involved in spatial memory. And this might actually be this brain cartilage. Might be and I am taking liberty with the word cartilage because it is a very specific molecule, these chondroitin sulfate clusters. But they might actually be part of how these neurons work together and part of the synaptic processing of information. This came from Cell Reports, and it's this brand new study out of University of Trento and the German Center for Neurodegenerative Diseases. I don't think I ever considered the idea that synaptic plasticity and chondroitin or the stuff that's involved in cartilage, that would go together. So this is I think this is a really interesting piece of work. And this started several years back and has been ongoing. These chondroitin sulfates were described back in 2007 by a Japanese research team. And they seemed kind of random, and then people kind of forgot about them. And then a group brought them back, and they've been studying them and have found that they are associated with glial cells in the brain. And when people have psychotic disorders, these clusters and the chondroitin are reduced. They've been looking at the function of these clusters, and they're organized not just randomly throughout the brain, but when they are located somewhere, they're in a recognizable geometric shape, according to these researchers. So they did experimental expression of this in the brain of in the brains of mice, and were able to really see how they affected the different neurons in the brain. I don't know. I think it's so cool. We think of the brain as a jello. Like, I don't know. I have always thought of the brain as something similar to like a jello mold or something. And to actually think that there is a much more solid structure, a scaffolding almost, that I think is fascinating. So I'd love to know more about how that's involved in disorders of the brain, in when people have brain traumas. How does that impact what's going on in the brain? And is the scaffolding potentially, if we could focus on the scaffolding, could we potentially help fix what's happening or the recovery of people who have undergone brain traumas, traumatic brain traumas? Yeah. Yeah. So Robert Varner in YouTube, you're saying you take that stuff for your joints. You're not old. No, but maybe it's helping your brain too. I don't know. But chondroitin, it's involved in your brain, your memory, learning spatial memory, synaptic plasticity. This to me is wonderful and incredible. And I don't know if you appreciate it as much as I do, but this is, I think, a very exciting discovery. And I hope that they look into it much more deeply. Because really, it's like, I don't know. It's very odd to think of little bits of scaffolding holding up little bits of brain, holding them together and going, okay, now you work together. What else does it do? I want to know. I really do want to know more. And then when we move, it does make me sad that Justin's not here right now. When we move from these cartilage-like structures, I would like to talk for a moment about a study that was published again in the journal Cell, and researchers created hybrid mice. They incorporated rat stem cells into mouse blastocysts so that the mice offspring that came from this union would have two species neurons in their brains. This experiment, we've had lots of experiments where they've tried to create chimeras and hybrid brains, put things together, and they've had limited success, but it's been growing as researchers have gotten better models and methods and been able to put things together more and more and more. And in this particular situation, the researchers were able to successfully integrate the rat neurons into the mouse brains. And in creating this situation, the mice were fine. They were totally like normal mice. So the question is like, okay, if you're a mouse with a lot of rat neurons, are you really a mouse or are you a rat? What's going on? How does that work? They behaved like mice. They didn't behave like rats, but they were absolutely fine in terms of how they developed and how they behaved. So the researchers then decided that they wanted to know more about what would happen if they disabled the rat neurons, and how that would impact the mouse behaviors. In this situation, so when they disabled these circuits, there was a difference in the ability of these mice in how they were able to behave. So in getting rid of the rat neurons, they found that if the mice didn't have their own neurons in there, their neurons weren't really able to work. And so there was just dysfunctional mouse neurons in there. And so the mice weren't able. Were the mouse able to smell it? The mice able to smell a cookie? If you give a mouse a cookie, anyway, they did that. They hid a cookie in every mouse cage, and they were able to find it with the rat neurons. But if the mouse neurons were silenced, they couldn't find it. If the rat neurons were silenced, it didn't quite work. The main point is that the researchers bring home is that replacing neurons isn't plug and play. You can't just, oh, you got a dysfunctional neuron, we'll put another one in. And so this potentially, what they hope is that the hybrid brains like this will not only allow us to understand more about our own brains, but also understand more about how we can repair and replace parts of the brain when brain cells get sick and die. So do you have to empty out the dysfunctional neurons first and allow time for the other neurons to develop? This is the question. If you give a mouse a cookie, if they have a rat brain, they're probably still going to like the cookie. All right, moving on to my final couple of stories really quickly here. Researchers have created little teeny tiny implants, nano-sized, they're neuron-sized implants that are going, hopefully, to be able to help people who have gone blind see again. These are brain interfaces that are specifically right now being created for the retina to replace damaged retina. These, what they call highly flexible, thin polyimide shanks, which have little tiny, less than 15 micrometer electrodes, are able to microstimulate neurons that lead to the visual cortex. And so it's not like, oh, yay, we put it in a mouse and they can see again. Whoop-de-doo. It's kind of like pixels of light. There's light, dark, light, dark. The resolution is not great, but at the same time, if they can upregulate or increase the resolution of the implants that they're creating, the hope is that one day they would be able to replace a damaged retina and be able to fully replace the damaged vision and the interface between how light comes into the eye and then gets turned into an electrochemical stimulus that moves on to the visual cortex. Because, as we know, I say we again, so I do that all the time, vision, it's not just in the eye, right? It's mostly our visual cortex. Vision and perception is mostly a result of the brain. So the initial tests have suggested that these implants can last at least as long as the lifetime of a mouse. So they could last for a long time, which could be really cool. Because one of the problems with implants is that we worry whether or not they'll have to be replaced. How long are they going to last? Are they going to deteriorate over time? What's going to go on there? How's it going to work? And so with these micro electrodes that they have created, these are nano-sized. They are individually able to interact with a neuron, which this is very cool. Who knows where it'll go? But it worked great. The mice were able to perceive light. This was something that lasted their lifetime, and it is something that could lead to treatments for people in the future. And I'm not going to do the sci-fi, where else could it go? But I hope that you'll do that yourself because so many places, everybody. But my final story comes back to this in a really big way because what do you do with an implant in your head when it's gone obsolete? So many of our devices in this world, oh my gosh, all you Apple people, I don't know, my dishwasher, refrigerate, planned obsolescence, or software updates. What if you don't want to? You've got a plug-in for your implant and you don't want to update the software because you don't want to mess up the way that it works with your brain. And suddenly you have a bricked implant in you. What do we do? What are we going to do? Researchers are talking now about this issue, which never was an issue before, but has now is something that people are talking about: tech abandonment and the idea that implants could potentially not be supported by their producers anymore. They have the researchers who have published their study this last week. They are acknowledging exceptions, like devices that are being tested in clinical trials. They are talking about things like Elon Musk's Neuralink. There are a lot of things going on, and they hope with this research that's been published in JAMA's Network Open that some regulations can be put in place. If an implant manufacturer goes bankrupt, what happens to the patient? Do you take it away? Does it stay? What's going to happen? So I think this is one of our sci-fi questions, right? This is our future, and how did we get here to even be considering this particular question? But I leave that to you all for the rest of tonight. I am on my own here. I'm sad that Justin had to run away, but he had to catch a train and go to work. I'd love to know what you all think. Do you have cochlear implants? Do you have other implants? Have you ever had an implant that stopped working? What happened? How do you deal with it? How would you deal with it? What would you do with old technology abandoned, not in a dump somewhere or in a pick and pull, but in your body? What are we going to do with that? So many questions for the future. I'm so glad that somebody's thinking about something these days. And I'm really glad that you are all here thinking about things with me. I do appreciate it. And to reiterate once again, for all you science moms out there doing all the science and the momming, I think you're amazing. It's not easy. And if you feel like it, you want to share, send me a note about being a science mom, what your experience is like, and I would love to share your experience with our TWIS community. Everyone else, I just want to say thank you so much for being here. Thanks for listening. Thanks for watching. I hope you did enjoy the show. Shout outs, Fada. Thank you for all the show notes and the social media and the support over the last couple of weeks with stuff my family's been going through. And Gord, Arnlore, everyone, thank you for keeping the chat room good places. Identity 4, thank you for recording the show. Rachel, thank you for editing the show. Everyone in the chat rooms, I see you. My Discord, I see you. YouTube, there's a Twitcher. Who else is there? Are there Facebookers? Are there Facebookers here? Anyway, I've got Facebook also, but I see you, and thank you for chatting, and thank you for putting your comments into the chat. I do watch them as they roll past, and I try to keep them in mind. And yeah, you're the reason we're here anyway, so I love being able to talk with all of you. Thank you also, of course, to our Patreon sponsors. I definitely have to say thank you to our TWIS patrons, Alan Viola, Aaron Anathema, Arthur Kepler, Craig Pottsberry, Gertz, Teresa Smith, Richard Badge, Bob Coles, Kent Northcote, George Corus, Pierre Villazarb, John Ratnaswamy, Chris Wozniak, Vegard Shefstad, Jonathan Stiles. Okay, good. I'm on the right page. That's awesome. AKA Don Stylo, Ali Coffin, Reagan Shubrew, Sarah Forfar, Don Mundis, PIG, Stephen Albaran, Daryl Myshak, Andrew Swanson, Fred S104, Sky Luke, Paul Runovich, Kevin Reardon, Noodles, Jack Bryan, Carrington, David E. Youngblood, Sharon, Sean Clarence Lamb, John McKee, Greg Riley, Mark Hessenflow, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Richard Brendan Minish, Johnny Gridley, Remy Day, G. Burton Lattimore flying out, Christopher Dreyer, Artyom, Greg Briggs. Hope you're having fun on that boat. John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Rick Ramus, Philip Shane, who's also doing some awesome documentary work these days and hosts the What If podcast. Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, Lon Makes, Schnago, I see you, EO, Adam Mishkan, Aaron Luthen, Bob Calder, Marjorie, Paul, Disney, David Simmerly, Patrick Pecoraro, and Tony Steele, an amazing artist who just is so sharing and giving of his work and is constantly improving and doing amazing things. I appreciate all the support from all of you. Really. I see you. Yes, Robert Varner. It's over already. It is. Maybe we actually hit a tight 90 tonight. Anyway, thank you. Let me finish, I guess, with what we normally do together, Justin and I. On next week's show, thank you for supporting us on Patreon. If you're interested in supporting us, you can find information at twist.org. There's a link to Patreon there. On next week's show, we're going to be back once again, broadcasting Wednesday at 8 p.m. Pacific time, live from our Twitch, YouTube, and Facebook channels. But if you want to listen to us as a podcast, you can look for This Week in Science wherever podcasts are found. If you enjoy the show, don't keep it to yourself. Make sure you share it with your friends and get them to subscribe as well. For more information on anything that you've heard today, show notes and links to stories are going to be available at twist.org. You can also sign up for our newsletter. I will send one again someday. I do love your feedback. I really love hearing from people. So if there's a topic that you want us to cover, address, or a suggestion for an interview, let us know. On one of our social media accounts, sometimes I check them, but you can also send an email. Just put TWIS in the subject line so that your email does not get spam filtered into a dysfunctional mouse neuron in a hybrid brain that a rat neuron thing is taking over. Oh my goodness. Everyone, we look forward to discussing science with you again next week, and we hope that you'll join us once again. And remember, if you have learned anything from this show, it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science. This Week